video. Practice problem from the book, directly from the back of chapter 1. It's problem 1.6. We're doing 1.6a today since we've only covered the dot product. This is a good exercise in learning the interchangeability of the two definitions of the dot product. So firstly, the problem states to find the acute angle between two vectors A and B. And I'm just going to rewrite it in case you can't see it up top. A vector is equal to 2a hat x plus 1a hat y plus 3a hat z. B vector is equal to a hat x minus 3a hat y plus 2a hat z. And utilizing the dot product, it's very easy to find the angle between these two vectors. But to be able to do that, you have to use both definitions. So I'm going to start out with the definition which was pretty easy and the one that you probably learned first, which was that A dotted with B is going to be equal to AX times BX plus AY times BY plus AZ times BZ. So this is the sum of the multiple of the components multiplied together. And with our two vectors, it's very easy. We use the unit vector notation. So we have, for the two x components, we do 2 times 1 plus 1 times a negative 3 plus 3 times 2, which should give us a grand total of 2 minus 3 plus 6, 5. So now we know the value of the dot product is 5. From here, we can use the second definition of the dot product to figure out the angle. So the second definition of the dot product is that A dotted with B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. And normally we put AB, which means the angle from A to B. However, the problem does state the acute angle between them, so sometimes that can be a little trick thrown in to make sure you're paying attention to the problem. But let's just solve this out for theta AB. So we already know this value. This value comes from here. We've already solved that. So now we have 5 is equal to the magnitude of A times the magnitude of B cosine theta AB. So 5 is equal to the square root of 2 squared plus 1 squared plus 3 squared, coming from the definition of the magnitude, times the square root of 1 squared plus minus 3 squared plus 2 squared times cosine theta AB. If we calculate this out really quick, this ends up being 4, 5, square root of 14 times square root of, looks like 14 again, cosine theta AB, which is 5. And luckily for us, square root of 14 squared, pretty simple. So 5 is equal to 14 cosine theta AB. So if we divide by 14, we end up with 5 over 14 is equal to cosine theta AB. And we end up with the result by multiplying each side by the inverse cosine. So operating on both sides by the inverse cosine, we end up with the cosine inverse of 5 over 14. I'll write that so you can actually see it. 5 over 14 is going to be equal to theta A B. And that will be your answer as soon as you compute out what cosine of 5 over 14 is. Pretty much, that's the whole problem. So just a recap of everything we did in this problem, we started out with two vectors, A and B, and we utilized both definitions of the dot product. So we started out by finding the value of the dot product by multiplying the components together and adding them up, so the first definition that we learned. And we found that equal to 5. We took that value, plugged it into our second equation for the dot product, which was A dot B is equal to the magnitude of A, magnitude of B, cosine theta between the two angles. And by plugging in all the respective values, we were able to come up with the answer.